Hello and welcome. Right now you're about to discover some of the powerful features of Geobase so that you can use Geobase to create interactive and captivating mapping applications. You'll see ship trails glide across a map with a way to easily query and explore the ship activity data underneath. This Geobase Quickstart blueprint showcases a range of features within Geobase, including automatically serving vector map tiles of your data. Geobase has a bunch of Postgres extensions built in, and you will use MobilityDB for temporal or moving data and PostGIS for geospatial processing. On the front end for visualization, you will use deck.gl and MapLibre libraries. But first, let's jump to the end and show the finished running application. It's called Northern Waterways, and you can see lots of ships sailing about on the waters around Denmark. The data is AIS data, or Automatic Identification System, and is provided by the Danish Maritime Authority. AIS is tracking for ships, like GPS, but with lots more data. Above the map, there are some links to move the map to some locations, so let's have a look. There's the Kiel Canal, which links the North Sea to the Baltic Sea, and is one of the busiest canals in the world. And we can see ships moving around the Swedish city of Gothenburg. We can have a look at the Øresund Bridge, which connects Sweden and Denmark. Most of the ships cross this part, but there are some that goes underneath it too. Here's one now. And back to the big picture, which shows the big picture of all the movements in the area. So underneath the map is the slider control. You can pause it, and then you can manually move the slider backwards and forwards to see the ships moving, and you can resume this. Now we can query the map to see counts of underlying ship activity represented as H3 hexagons. And to do this, we start by clicking on the Draw to View Activity button and draw a polygon around the area. This then passes it to Geobase and returns a count of activity grouped into hexagons. You can see that certain areas are much more active than others. And we can click on the button to clear the map. Now to get started, we need to load in the data and create the tables and functions, and then set up the project and run it. So within Geobase, we click on the SQL editor, choose one of the Geobase Quickstarts. We've already provided one called Ship Movement Analysis. We can click on that, and to run that, you can just press Run. The other way of doing it is using PSQL, and you can find these details in the README. A couple of environment variables in the .env local file need to be set. You can find these in your Geobase project settings page. So the Quickstart SQL file, which we'll look at shortly, imports the data, sets up the tables, and makes the functions that we need. And there are two main groups of tables, the AIS tables and the ship table. And there are two functions, the ships function and the activity by region and time local function. The ships function produces the vector tiles, and the activity by time local is the one that produces the hexagons. Let's have a closer look at the AIS table. So within our table editor, we have the AIS table. We can see there's timestamps, classes, the MMSI, that's the identifier. We've got latitude and longitude. Basically, each row is a point, and you'd have many rows for one ship. So let's have a look at the SQL file in more detail. The first part imports and sets up the AIS data, including converting latitude and longitude into a PostGIS geometry. Geobase actually includes the subset of the 3.5 hours, and that's about 500,000 points. And next we create our geometry, do a little bit of cleaning up add the row level security to the table, and then we set up the ships table. And here we basically want one row per ship, grouping on the MMSI, and we want all the points together into one sequence of points with time. We also apply some simplification here to reduce the jitter and tidying up the data, and also using MobilityDB we can get a time-weighted average of the speed over ground and the speed of the actual trip and compare the two together. Now onto the functions. The ships function takes in the ZXY, and this is the tile server function. Now I did say that Geobase automatically creates vector tiles from your data, and it does this for the ships function. So if we have a look in our database and our functions list, we should see our ships function listed there, and we can see it's already have our map tiles, and we can have a look on the integration example to see what this looks like. We just need to change a little bit of code to change from type point to point line, and zoom into our area around Denmark, and there we have our ships as vector tiles, but of course they're not animated. So a feature in the vector tile has an array of coordinates and a property with timestamps, and within the code itself we use deck.gl MVT layer to load in the vector tiles, and we use render sublayers so that for each tile it passes in the data and creates a trips layer, which is the animated trip, and that needs the path from the coordinates as we saw and the timestamps. And so to finish, we're back at the application showing animated ship trails with an interactive activity query. Hopefully using this quick start you can use Geobase to power your own movement and mobility enabled geospatial applications. Thanks for watching.